Welcome you all for this session on cause-effect graphing. Before starting with cause-effect graphing, let me give a brief overview on black box testing. Black box testing, otherwise called functional testing or behavioral testing, is used to evaluate the functionality of a software. There are so many techniques to design the test cases for black box testing, and cause-effect graphing is one such technique. Now we will see what is cause-effect graphing. Cause and effect graphing can be used to combine the input as well as output conditions and to derive an effective set of test cases that may disclose inconsistencies in a specification. The input specification must be transformed into a graph that resembles a digital logic circuit. Developing the graph for a complex module with many combinations of inputs is difficult and time-consuming. These are the steps involved in cause-effect graphing. First, the tester must decompose the specification of a complex software component into lower level units. As a second step, for each specification unit, the tester needs to identify causes and their effects. By cause we mean a distinct input condition or an equivalence class of input conditions, and effect is an output condition or a system transformation. Third step, from the cause and effect information, a Boolean cause and effect graph is to be created such that the nodes in the graph are causes and effects. The causes are placed on the left side of the graph and effects are placed on the right. The logical relationships between the causes and effects are expressed using standard logical operators. And here we see some of the causes and effects which are combined together using logical operators. The first one shows that the effect 3 occurs only if both the causes 1 and 2 are present. And here we see that the effect 2 occurs only if cause 1 occurs. Finally, this graph it shows that the effect 2 occurs if the cause 1 does not occur. As a fourth step, the graph may be annotated with constants that describe combinations of causes and or effects that are not possible due to environmental or syntactic constraints. This graph is then converted into a decision table, and the columns in the decision table are transformed into test cases. Here we illustrate the cause and effect graphing using an example, that is a character search, which means a given character is to be searched within a given string. Now let me read the specification, which says the user must input the length of the string and the character to search for. If the string length is out of range, an error message will appear. If the character appears in the string, its position will be reported. If the character is not in the string, then the message not found will be output. Now here we identify the input conditions, that is the causes, and the output conditions called the effects, and then here we have the rules or relationships which combine the causes and effects. So under causes we have C1, which says a positive integer from 1 to n must be given as input for a string of length 80 characters, and C2 is the character to search for in the string. Then the output conditions are effects. E1, it means the integer out of range. E2 is the position of character in string. E3 means character not found. Now, based on the specification and the derived input and output conditions, they are combined together so that the specification is mentioned in the form of this cause-effect graph. So here are the rules and relationships, that is, if C1 and C2 are true, then the effect is E2, and if C1 and C2 is not true, then the effect is E3. Then if C1 is not true, then it results in effect E1. Now we'll see how to construct the decision table from the state transition graph. Our decision table will have a row for each cause and each effect. So we see that there are 5 rows altogether for 3 effects and 2 causes. The entries in this table are a reflection of the rules and entities in the cause effect graph. Like here, the entry 1 represents a cause or effect that is present, and an entry 0 represents the absence of a cause or effect, and a dash indicates the don't care value. So here we can refer to the cause effect graph, and accordingly it can be translated in the form of a decision table. Now we have the entries 1 and 1 for C1 and 1 for E2, meaning that C1 and C2 must be true for the effect E2. Similarly, the second relationship, it shows that C1 must be true so that E1 is true, and T3, it shows that the effect E1 is reached only if C1 is false. So we have the entry as 0, and wherever we have the entry as 0, it means the condition should be false, or it means that correspondingly the particular effect does not occur, and a dash here, it shows that the value is immaterial. Now with this we have seen the various steps involved in cause effect graphing, and also we have seen an illustration with a character search example.